good morning, my dear students. I think you all have seen me. I am Dr. Lata, heading Computer Science and Engineering Department in AMCEC. I think you all would agree with me that computers have become an integral part of every second in your lives. Right? Maybe the applications of machine learning, Internet of Things, fuzzy logic, artificial intelligence, or e-commerce, your favorite e-commerce. Now, these words would look like alien words for you all, as if now, for some of you. But after 4 years, you will be well versed with all these technologies and you will be in a position to impart this knowledge to the rest of your friends or your juniors. That's why I asked your seniors to take up all these topics and introduce these technologies in today's session. So your seniors, Mr. Shayan, Karthik, Revati, Vamshi, Nishank, and Arjun will be taking a walkthrough to all these technologies in the short span of time today, so that you will have an idea about what you are going to learn in all these 4 years. But you might think, why your seniors, why not your teachers? No, I just wanted to send you two messages through this. One is, you will be knowing how, you'll be just imagining how you would spend your days in AMCC 4 years. It's not just video syllabus, not just classroom, not just labs or IA tests or exams. Just something beyond that. You will be exploring the technologies, the state-of-the-art technologies, and you will be imparting the same to your juniors or to your friends. That's one thing. Second thing, I observed so many of you were worried about ragging when I read through the chat box of YouTube screen in that inaugural function. So many of you raised the issue of ragging. In AMCC, there is absolutely no ragging, right? It is just this relationship of knowledge sharing, knowledge imparting from seniors to juniors. Just like today, your seniors are taking your a walkthrough in all these technologies. So when I asked them, they wholeheartedly accepted, and actually they were also coming to me for the same purpose, and it's like, you know, we both approach for the same purpose. And they are very overwhelmingly ready to give their knowledge, whatever they have learned, and today they will be presenting the same thing to you all, the team, and I wish you all will have a 1 hour of knowledgeful time. Okay, over to your seniors.
Action.
Hey, I'm Shayan from the Department of Computer Science and Engineering, and well, let's dive right into your student induction program. So, what would we normally be here to talk about? So, there's a lot to talk about. We could talk about your the 4 years that you have in college. You could talk about the 8 semesters that you have, and there's maybe 7 to 8 subjects that you have in each semester. But that's not what we're here to talk about. Let's dive into something a little more interesting. Like this game right here. Now that was augmented reality. Now with augmented reality, there's another technology that's constantly associated with it. This virtual reality. Wow. That is beautiful. Well, what is virtual reality? And what can virtual reality do? Let's take a deep dive into this. understand from that, what is the difference between AR and VR, augmented reality and virtual reality? Augmented reality helps you bring digital content into the real world in an immersive way. But virtual reality, on the other hand, is an even more immersive technology that lets you immerse yourself into the digital world. That is the difference between augmented reality and virtual reality. But that begs one question. Why? Why do we have these things? Why did we just decide to invent technologies like augmented reality and virtual reality? Well, think about this for a moment. All of the technology that we have today, all of our screens, our phones, our laptops, our projectors, our TVs, all of these things are in 2 dimensions. But we as humans see in 3 dimensions. So there's definitely a gap there between where technology is today in terms of displays and how we as humans see the world. And that is the gap that is being bridged through AR and VR. Now how do we achieve these things? Well, it's simple. Devices. All of this is done through devices. You've got so many devices. You've got headsets, you've got tablets, you've got smartphones, you've got all of these things, all of these devices. You've got things ranging from some of the cheapest and lowest end models like the Google Cardboard that you can get for just 150 rupees to something high end like the Oculus that can cost up to 70,000 rupees. You've got all of these devices. So that is how we do it. But think about this for a moment. What is the difference between the devices that you might use for AR and VR? So for virtual reality, you require specialized headsets, goggles, controllers, all these things. But what are the devices that you might require for AR? Well, you could do it on a phone, you could do it on a tablet, you could do it on practically anything with a camera. And that is why AR is much more implementable than VR. And AR is the biggest upcoming market. It is something that will completely revolutionize the future of technology. I'm going to show you the market size of AR in 2016, 17 and 18. And I want you to figure out the market size in 2022. So in 2016, it was $6.1 billion. In 2017, 14.1. 2018, 27. So can you figure out the market size in 2022? So think about it, do the math for a bit. 16, 14, 27, what's next? You'd say it might be 54, 51, 50, 30, nope. $209 billion. That is how big AR is going to be. It is going to be the single biggest upcoming industry. Bigger than machine learning, bigger than IoT, bigger than every other industry that you could think of. Where can we use this? What are the applications of this? So you could use this for entertainment, you could use this for gaming, you could use this for accessibility, real-time translation, you could use this for education, you could use this for healthcare. Take a look at where HoloLens is being used for healthcare. Like Lenskart and Warby Parker have this really cool thing where you can 3D try on. You could have tons of uses in the military, industrial equipment training, by providing not just buttons, but an actual interactable real-world interface right in front of you with graphical and user-friendly annotations. So this is the future of the digital space, augmented reality. AR is the future of technology. It is something that will completely revolutionize the digital space entirely. But that is not what we're here to talk about. what we're here to talk about today is the world of machine learning. Now, let's get right into it, in fact. So, what is machine learning? What do you understand by the terms ML and AI? So, from the word itself, what you can decipher is machines that learn, right? Artificial intelligence. Intelligence that is, very bluntly putting it, artificial, right? But let's take a more deep dive into this. I want you to stop for a moment and just take a look around you. Take a holistic approach to understanding what is the technological progress that we are making so far, and where does humanity stand currently in the field of machine learning? Where are we? Where do we want to get? To answer this question in greater depth, I'm going to take you back in time to the dawn of humanity. Yes, that far back. And if you think about it, from the dawn of humanity, everything that humanity has been doing is we have been creating tools. We have been developing and creating tools that can help us do our work better. Right from the Stone Age, we created tools that look like this. A few centuries later, our tools evolved into looking like something like this. This was the industrial age. And that continued to evolve. And currently, our tools look like this in the digital age. But there is one thing in common. Ever since the dawn of humanity, ever since the invention of the wheel to the tools that we have today, there is one thing in common. And that is that all of these tools are instructed by humans. The chisel only struck where you struck it, right? The computer only does what you ask it to do. But for the next era of tools of humanity, we want to create something that is drastically different. We want to create tools that can function independently. We want to create tools that are smarter than us, faster than us, stronger than us, better than us in every possible way. So it is a drastic turn that we are planning to take for the next era of tools. And how do we do that? Where are we currently? The truth is, these tools in some primitive form already exist today. May it be something as simple as the assistants on your phone, the voice assistants, or something as primitive as to some form of single player AI that plays against you in your mobile games. Yeah. But the thing is, it's not just in games and assistants. We use some form of AI every single day around us. In fact, every single social media uses some form of primitive artificial intelligence. Maybe something as simple as to curating your newsfeed to show you the content that you want to see, to something a little more complex, such as analyzing consumer behavior, identifying trending topics, brand passion and sentiment. So, much more complex analysis related to these things. All of these are done using some form of primitive AI. Even multiplayer games to this day run on AI. So, but the thing is, AI is doing much more than just playing games against you like this. Um, what you might say. Let's say the game of Go, right? By looking at this, you might say this looks exactly like chess, right? But how is this anything more different? How is this anything more advanced than playing the game of chess? Well, for starters, the total number of possible moves in chess is 121 million. All right. So I want you to take a look at this for a moment. 121 million moves in chess. Now that might seem like a lot, but the truth is computers today are so powerful that they just explore the entire solution space. They just explore all possible moves and they've got basically got a cheat sheet on hand to play this against you. So this isn't exactly as challenging as it might seem. But Go, on the other hand, do you want to take a guess as to how many possible moves this can have? It's 10 to the power 360. Yeah. To give you a better understanding of what that looks like, this is what 121 million looks like. And this is what 10 to the power 360 looks like. Yeah, that's a lot of zeros. Turns out this happens to be more possible moves than the total number of atoms in the universe. Yeah, that's right. More moves than the total number of atoms in the universe. That's a lot of moves. And obviously, that's impossible for any computer this day until now to explore the solution space. So, if you want to solve a problem like Go, you would actually have to develop some form of more advanced artificial intelligence to actually play this. And it's much more complicated than just exploring the solution space. So, obviously, the developers put this to the test, and Google DeepMind developed a program called as AlphaGo. And AlphaGo, so what was different about AlphaGo is that AlphaGo was never taught how to play the game. AlphaGo was just given the rules of the game, and it was asked to learn on its own. They left it running for over thousands and thousands of simulations, and eventually the game learned to play Go on its own. They put this to the test. So they put AlphaGo against Lee Sedol, which was the 18-time world champion. And you want to know the results? AlphaGo won 5-0. That's right, against the 18-time champion, 5-0. That is significant in the game of Go. And so this was so advanced that the truth is this was an artificial general intelligence. So what happened was it was making moves that the community had never seen before. In fact, some of the strategies that it was using was so different that no one had ever seen before. At some point, the developers couldn't understand what exactly it was doing. Today, these strategies that AlphaGo made that day, are being used to train the new generation of Go players. That is how significant it was. Now, I said it is an artificial general intelligence. What does that mean? So the thing is, this AlphaGo was not just created to play the game of Go. It was a general intelligence. So what happened was the same algorithm, the same learning approach that it used to play the game of Go, it could also apply the same approach to solve other problems. So what happened? What they did was they took the same general intelligence and tasked it with the problem of reducing the power consumption on Google's data centers. And the result, AlphaGo was able to reduce the power consumption by 40%. That is significant. It was something no human engineer was able to achieve. You have deep learning. What is deep learning? You also have something called as machine learning, and you have something called as artificial intelligence. So what are these concepts? Some people tend to use these concepts interchangeably, but what are they really? Are they interchangeable? No. So the thing is, deep learning comes under is a subset of machine learning. But what is machine learning? Well, machine learning comes under the umbrella of artificial intelligence. This is what that might look like. So the thing is, artificial intelligence is merely a concept. It is a concept that deals with machines being able to think on their own. Machine learning, on the other hand, is algorithms. They're algorithms that learn and improve as and when they get more data available. But deep learning, on the other hand, is multi-level neural networks, and they deal with large amounts of data. And what this AI does is you can give it some basic drawings, like something that you might draw in paint, and it converts those drawings into lifelike pictures. So let's say I would draw something very simple, something like this, something that a child would draw in paint. So this is the input that I would give to the AI. And do you want to see the output? This is the output that you get. Exactly. It converts it into such realistic, hyper-realistic, lifelike images. Machine learning and artificial intelligence is the future of technology. But that is not what we're here to talk about. We're here to talk about IoT. Wait, hang on. Hey Siri, turn on the lights. That was IoT, the Internet of Things. Now, what is IoT? Well, it's got a bit to do with communication. So just think about this for a moment. There are 7 billion people on the planet. Now, just imagine for a moment if there was no communication. We would have made no progress as a society. There would be no buildings, no innovation. We wouldn't have the things that we have today. all of which has been made possible through communication. Now think about this. The number of devices on the planet. There are 22 billion devices on the planet. Now just imagine if there was some standardized way where all of these 22 billion devices could interact with each other, maybe communicate to each other, ask each other different things, provide information, tell each other different things to do, work together in synchronous harmony. Your surroundings would be a much better place. For things as simple as maybe turning on the lights when you walk home, or maybe even opening your front gate when you ride outside. Things like alerting you when someone breaks into your home automatically. All of these things are realized through IoT. All of this is done through a combination of hardware and software. Take, for example, sensors like this. This is a PIR sensor. This is used for motion detection and occupancy. Now you might also have switches like this. This is a relay. This is the industry standard for a smart switch. Now to control all of these things, you might need the brain of all of these operations. So for that, you might use something like this. This is a Raspberry Pi. This is the industry standard and has to be the most famous IoT device. All of your computations, all of the processing that you might want to do, all of it can be done on a Raspberry Pi. Now, if this isn't the thing for you, if you need something a little more simpler, well, you might also use something like this. This is an ESP module. So this does all of the same things that you might want to do on a Raspberry Pi on a much smaller form factor. So that was just some of the hardware that you might want to use. But hardware is only part of the story. When you've got all of these devices with you, the next thing you might need is an interface, a channel for all of these devices to communicate with each other. So what do all of these things have in common? So all of these things have Wi-Fi. So all of these things have one common channel that you can use to interact and communicate with each other. So you could have Wi-Fi, but you might also have something else like Zigbee or Z-Wave or even Bluetooth. So all of these are standardized channels that you can use to form a network of devices. So now that you've got all the devices and you've got them on the network, the next thing that you might need is a common language that all these devices can use to communicate with each other. So you've got multiple things for that, and that's where APIs come in, application package interfaces. So some of the most common APIs for inter-device communication with IoT would be MQTT and the REST API. So MQTT is a server-side standard, whereas the REST API can work locally between your devices. So that establishes a hardware and software interface between the devices that we talked about, the most basic implementation of Internet of Things. Now remember when I talked about local and server-side? Yeah, so that is another big picture when it comes to the Internet of Things. You have devices that you could control locally that interact on your home network around you. Or you could even have devices that talk to the cloud. So that would be server side, the ones that talk to the cloud. And if you have devices that work on your own network, that would be local devices. So when it comes to server side integration, you've got tons of companies that provide this sort of support, cloud support, as well as manufacture their own devices. So you've got Philips Hue, one of the most common IoT devices with their color changing lights. You even got Nest, that is famous for its cameras. So you've got all of these companies that provide server-side control and manufacturing of their own devices. Now, how would you actually link these devices with your own personal devices like smartphones or your other gadgets? So that can be done using Google Home or HomeKit. Now both of these things work on different technologies. So that is another problem coming to that. So this is where some of the issues start. So when you have companies making their own devices and selling them to you for cloud support, that is where subscription fees comes into the picture. Another thing to note is that all of these devices that these companies make, and even the protocols that they run on, like the Google Home and HomeKit interface, all of these things are different protocols. They're different languages. That is where the biggest problem of IoT comes in. Platform fragmentation. When all of your devices work on a different protocol, speak a different language, and require you to subscribe to their services that might only work for the next 2 to 3 years down the line, your devices would be rendered meaningless in the next 5 to 10 years. So platform fragmentation is the biggest problems in the world of IoT, but there is work being done towards it. Recently, companies like Apple, Amazon, Google, and much more have created the Open Home Alliance. The Open Home Alliance attempts to unify all of the devices, the IoT devices that we have today, under standard, common, local protocols and eliminate the entire concept of platform fragmentation. One of the biggest milestones that are coming up for the Internet of Things is platform unification.
Well, hold on a minute. That's not what we're here to talk about. We're here to talk about app development. Now, app development has come a long way since the early ages. First, we have had native app development for both Android, iOS, Windows, and other platforms. We used to use Java for the Android development and Swift for iOS development. But we have come a long way from that. Today, we use one code and develop it for all the multiple platforms. We are here to talk about Flutter. Flutter is one of those languages in which you can write the code one time, compile it for all the platforms. Now, if you can see, this is one app called Reflective. This app was made by Flutter, and this is one of the most beautiful apps in the whole of Play Store. So you can add your nickname, and this is a private journal. There are other apps like this. Your Google Assistant which you use, that itself is made in Flutter. Alibaba Group, Baidu, Tencent, all these famous companies, they use Flutter. Google Pay also has been announced to integrate into Flutter in the upcoming months. Now, Flutter is a lot of things, but it also lacks in one main thing: community support. Well, Flutter was introduced in 2017, so it is relatively new. Thus, it has very less community support as of now, but it is rising very much. Now, we can develop apps using the Dart programming language. Now, remember, Flutter is not a programming language. Dart is a programming language. We can create apps which are very animated, very fluid, and it can give the native experience of how a normal app would. The Flutter uses the Java JIT compiler, just-in-time compiler, to compile the apps in real time. Now you can ask me, what is the difference between Flutter and React Native? Well, both are good programming languages. Both are open source. Flutter was created by Google and React Native was created by Facebook. Both are well maintained, but the advantage is that Flutter is developed by Google, and even the backend Firebase is also developed by Google. So, Flutter has a very supported integration with Firebase. The other thing is, Flutter is really easy to code. A person with no programming language experiences can also code Flutter, and they can make beautiful apps. Now, what is the flaws of a cross-platform application language? The thing is, no matter how easy it is to code, we can still miss out on some things. For example, it is not as easy as it is to access hardware components like camera, Bluetooth, and other stuff. It is accessible, but it is very difficult. Apart from that, both of these languages offer good integration for APIs and other backends. Oh wait, but that's not what we're here to talk about.
We're here to talk about quantum computing. So let's think about the most pressing questions in the world right now. Will this vaccine work? What will climate change do to the world in the next 50 years? Can we model the human brain accurately? Can we reverse aging? How much would billionaires give out of their billions just to go back maybe 20 years in time? How do we answer these kind of questions? Well, here's the thing that we have to consider. Our world is quantum. Nature is quantum. Everything around us is quantum. But our computers are classical. Wait, let's take a step back. What does it mean? What does it mean for computers? What does it mean for things to be quantum or classical? Well, here's the thing. In classical computing, you've got bits, binary bits, where a bit can either be a 1 or a 0. But in quantum computing, you've got qubits. Quantum bits exhibit something called as superposition. That means the same particle can either be a 0 or a 1, or even something in between at the same time. Quantum bits can also be entangled. That means two particles, irrelevant of distance, can be physically linked to each other, and their state only gets resolved when you observe them. Everything in nature is quantum, right from something as simple as a leaf to something as complicated as the human brain. Everything is quantum. So that means everything around us constantly exhibits quantum entanglement and superposition. When you want to model something on the classical computer, you would have to evaluate their states one state at a time. But a quantum computer can simultaneously calculate these probabilities in real time. Do you know, to this day, we still cannot model a caffeine molecule on a regular computer. The compute time directly moves to infinity. So how would you answer questions like these using a classical computer? That is where quantum computing comes into the picture. To achieve quantum computing, we have to cool down computers to minus 273 degrees Celsius. That is absolute zero. That is why you have all these huge contraptions just to cool the system down. All of this is nothing but the cooler. Or in terms of how far we are in terms of the size of quantum computers, we've achieved up to 53 qubits so far, which is nothing compared to the density of the latest classical computers with up to over 11 billion transistors. So once quantum computing makes its way into reality, our questions go from will this vaccine work to implementing clinical trials to actually running simulations on every single model and understanding them. From mathematical estimates to real world calculations. All of these things can be quantum computed. Our digital security, for a classical computer would take 300 trillion years to crack, our quantum computing could crack them instantly, which is why our digital security would go from math to being governed by nature itself. Our speed times would go from internet speeds to instant communication due to quantum superposition. That is what we can achieve in a world where our computers are governed by quantum mechanics. Wait, what exactly were we here to talk about?
Wow,